Hello everyone, we're going to talk about 3-1 dilations, more specifically the notes to it. So we have to figure out how is this dilation affecting the original object? Is it enlarging it? Is it reducing it? And what is the scale factor to that? So when we look at this, for example, it says, hey, from the left to the right, how is it enlarging? Is it a reduction? And what's the scale factor? Now, you don't look at the shape itself. You just have to look at the information they give, like how long is the length comparison to the length they give on the other one. So if we look at it, we can see that the left is 6 inches and the right is 18 inches. So we're going to write this out. We're going to write, hey, it's going to go from 6 inches to 18 inches. So there's actually an equation we can write. We can write 6 inches. And now, let's type it in. Let k equal, lowercase, equal the scale factor. So, knowing that, it's right there too. Knowing that, we can write this out. 6 inches times k is equal to 18 inches. Now, all we have to do is solve for k, and we'll figure out what is the scale factor. So what's the opposite of times 6? Divide by 6. But what's the opposite of times 6 inches? It's going to be divide by 6 inches. So we have to make sure that we divide by 6 inches on both sides. After we do that, we'll cancel out the left and they'll only deal with the right. Inches divided by inches cancels out. And 18 divided by 6 is 3. So the scale factor is going to be 3. What does this mean? Well, this means that, let's move that away. This means that the figure on the left is dilated, has a dilation that is an enlargement with a scale factor of 3. So if it's bigger than 1, it's going to be an enlargement. If it's between 0 and 1, it's going to be a reduction. Think of this way. Half. If it's increased by half, or if it has a scale factor of half, it's going to be half as big. So if it's 4, it's now 2. That's going to be half as big. All right, let's go on to the next one. Let's do another one just to work it out. We're going left to right. Now remember, we don't care if it looks big and looks smaller. We care about the numbers because somebody could have drawn it wrong. So let's write out our equation. It's going to go from 9 feet times k to 6 feet. All right, well, how do we get rid of times 9 feet? We're going to divide by 9 feet on both sides. So if we divide by 9 feet, we're going to see that there's going to be a little problem. It cancels out 1. This feet cancels out, and we're left with 6 over 9. But that's going to be a problem. We're going to have to divide by 3 on the top and the bottom right here. So we get 2/3. So what does this mean for this problem? Well, this means that, hey, this dilation is a reduction with a scale factor of 2/3. So it's only going to be 2/3 as big. It's getting 1/3 smaller. It's going to only be 2/3 as big as the original. All right, well, let's go on. So I actually like this one right here. Now we're dealing with coordinate geometry. So our first coordinates, let's put it in as green. Come on, drawing right here. This is going to be S right here. So we're going to draw this in. Let's say this is S, 0, 0. T is -5, 0 right here. So let's put T. And then V is -8, -8. So right about there. I'm going to put V right here. So they want us, well, it's a triangle, so why don't we connect the vertices or the points right here? So here we go. There's our triangle. So the scale factor is bigger than 1, so it's going to be bigger. So let's figure it out. Now, with the scale factor, you're going to multiply every number by 1.25. So this one's really nice. 0 times 1.25, so I'm going to write times 1.25. So 0 times 1.25 is 0. So S prime. So that's what we say. The new point is going to be called prime. S with a little hash mark right here. That's S prime. So that's the new transformation. In this case, the transformation is a dilation. So it's going to be 0, 0. Okay, fine. Now, if when we times 1.25, that's the same thing as timesing 1, and then timesing it by, well, dividing by 4, and then adding that. Well, let's see what I mean. 1/4. When I multiply that to -4, 1 times 4 is -4, and 1/4 of -4 is -1. If I add those together, I'll get -5. So t prime is going to be -5, comma, 1.25 times 0 is 0. Done. This last one's a little bit harder. I have -8 times 1.25. So I know it's going to have -8 times 1. That's it. I'm going to divide by 4. -8 divided by 4 is 2, so it's going to have plus this -2 part. So it's going to be -10. So v prime is going to be -10, comma, -10. All right, well, let's plot it. Let's do purple right here. So I know -10, -10 right here. S prime is the same location. And then T prime, the new location, is going to be right there. Well, now we can do our shape. We can do purple on purple, or we can do a different color. Let's do red. So it's going to look about the same. Just it's going to look 1.25 times bigger. In fact, this yellow and red line coming, if you have a side coming straight off of the origin, it's going to look, nothing's going to change on that. It's going to be on the same origin right there. Like that line should look exactly the same. Looking at this side right here, it looks pretty good, except now it's going to be parallel. So we're going to see a lot of parallel lines, and that's because similar shapes have the same angles. And if it has the same angles, it's going to be most likely parallel. All right, let's go on one last one, okay, guys? We have 2 minutes. Let's see if we can get this. Now, we don't need to do every single one. We only need to do one. So let's do G. So we know it's going to be similar. So G is at 0, 2. And it's going to go to G prime, which is at 0, 3. Well, 0 to 0 doesn't do anything for us. We multiply, can't get it. But 2 to 3. So I'm going to write this out. I know I'm going to go from 2 and I'm going to go to 3. What's the scale factor? Well, just divide by 2, because the opposite of times 2 is divide by 2. And we get k is equal to 3/2. So we can explain this and say, hey, well, let's move that out of the way so it doesn't get in the way. The dilation from D triangle DFG to triangle D prime F prime G prime has, oh no, what happened here? Bring me back. All right. Has a scale factor of 3/2. This means it is an enlargement. All right, guys. Thank you very much. I'll see you in class if we're in class together. If we're not, hope you guys are doing well and stay safe and healthy. Bye, everybody.